First thing we need to do in this question is substitute in the values of 3 and minus 70, x equals 3 and y equals minus 70 into this function. Minus 70 will equal 3 cubed plus 3 squared times a plus 3b plus 11. All I've done is substitute in 3 here where I see x and minus 70 where I see y, and I end up with minus 70 equals 27 plus 9a plus 3b plus 11, and just simplifying that we get 38 plus 9a plus 3b, and we get minus 108 equals 9a plus 3b, and that's enough for now. So that's the first part of the question. The second part of the question asks us to use the fact that this is a stationary point. So in other words, the gradient at this point is 0, and the way to find the gradient is to find the derivative of this function here. So we're going to find the gradient function. We're going to differentiate this function with respect to x. dy by dx will equal 3x squared. Remember, we take the power down and take 1 away from the power, plus 2ax plus b. And we know that where there's a stationary point, the gradient is 0. So 0 will equal to 3x squared plus 2ax plus b. We also know at this point x equals 3. So substituting in 3 here for x, we end up with this, which if we simplify, we get 27 plus 6a plus b, and we end up with another equation involving a and b. So that's part C. Part B. Part C asks us to use these two equations then to find a and b. These are simultaneous, these equations. A couple of ways to do this. We could either use elimination or substitution. In this case here, I'm going to, I think, use substitution. So what I need to do is I'll label this equation 1, this equation 2. If I multiply equation 2 first times 3, I will get minus 27 times 3 equals 6a times 3 plus 3b. So I'm multiplying everything in this equation by 3. That keeps the equation the same. 27 times 3 is 81. So I end up with minus 81 equals 18a plus 3b. And I'm going to call this equation 3. So equation 1, take away equation 3. I end up with minus 108 equals 9a plus 3b, and I'm going to take away minus 81 equals 18a plus 3b. I could have done this the other way around. Minus 108 minus 81, which equals 27, minus 27. 9a minus 18a equals minus 9a. 3b minus 3b is 0. So we end up with minus 27 equals minus 9a. A will equal minus 27 over minus 9, which is 3. And that then, if I substitute that into either of these equations, I could substitute it into equation 1 or 2 or 3. The simplest one to me looks like equation 2, so I'm going to substitute into a 2, and I'm going to get minus 27 equals 6 times 3 plus b, and that would then imply that minus 27 equals 18 plus b, so b will equal minus 27 minus 18, which is minus 45. And I can check these answers and make sure I'm correct by substituting these back into equation 1, which is the same as equation, I can put it into equation 1. Notice that I put the minus 45 into brackets here. I like doing that with negative numbers. It helps me to not make a mistake here, or it minimizes my mistakes. Minus 108 would equal 27 minus 135, and 27 minus 135 is 108. So that is correct and shows that I've got the correct answers here. And part D, the last bit, asks me to determine whether this point, this stationary point at 3 minus 70 is a local maximum or a minimum. And I do that by finding the second derivative. Remember, dy by dx was 3x squared plus 2ax plus b, and so with my new values here of a and b, I can work that out fully. So I'll get 3x squared plus 2 times 3, which is 6x, and then I've got minus 45. So 3x squared plus 6x minus 45. So I want to now find my second derivative. So I differentiate this gradient function, the first derivative, again. I end up with 6x plus 6. That's my second derivative, and this is useful, or one of the uses of this is to find whether we have a local maximum or a local minimum at this point, where x equals 3, because it was at the point 3 minus 70. So if we put 3 into here, we get 6 times 3 plus 6, which is 18 plus 6, which is 24. So because that's positive, we know that this is a local